So this is an important table here. We've got three different particles in the nucleus. In the atom. Protons, neutrons, and electrons. So protons and neutrons are about the same size. If we look here in this table, we see the mass of a proton is 1.67 times 10 to the minus 27 kilograms. That's really, really small. The mass of the neutron, minus 1.67 times 10 to the minus 27 kilograms. The difference here comes in the fourth significant figure. They're very close to the same. And they are so small that difference, for the most part, doesn't matter. If we look at their mass in atomic mass units, they're basically the same, 1 atomic mass unit. So these guys have the same mass. Their charges are different, though. The proton is positive. The neutron is neutral. We need to have the charges and the relative sizes and whether these are inside or outside the nucleus. Those are the things we really, really need to know. So neutrons are neutral, protons are positive. Therefore, the electron must be the negative one. So the electrons are negative, with a charge of -1. So inside the nucleus, you've got protons and neutrons. The nucleus has a positive charge. Outside the nucleus are the electrons. The electrons have the negative charge. Overall, the atom has no charge, and so the number of protons is equal to the number of electrons. And if we compare these guys, the sizes here, you see that the electron is much, much smaller. It's about 1,800 times smaller. So the electron is 1,800 times smaller than a proton. Much, much smaller. If we said that a proton was the size or had the mass of a baseball, then an electron would be about the size of a grain of rice. So that, it helps to bring these into real life perspective. Baseball versus a grain of rice. Baseball's a lot bigger than a grain of rice. Proton's nearly 2,000 times as massive. So, matter appears to be solid, but why did most of those particles go straight through the gold foil? What's in an atom? Mostly empty space. It's a little bit like a jungle gym, right? If you back up and look at the jungle gym, all those lines kind of cross over each other. They kind of all cross over each other, and so it might look like a solid from a long distance. But when you get close or you line it up just right, you can see there's big tunnels of openness. And so could you shoot an airsoft gun through this play structure? Sure, you could, because it's mostly empty space. There's metal bars there, but it's mostly empty. Now, if you took an airsoft gun and you just shot a lot of things at this play structure, occasionally you would hit something and it would bounce back at you, but most of the time it would go through. It's even easier to think about like a volleyball net. You've got the strings in the volleyball net. Most of it's empty space. And if you're shooting airsoft pellets at it, they're mostly going to go straight through, but occasionally one will hit and bounce back at you. It reminds me of those videos where somebody's doing something and you're throwing a ball and there's this telephone pole, this little tiny telephone pole and all this space, and it just happens to hit the telephone pole and come back and hit them right in the head and knock them over, right? And then it goes all over on the internet because people think it's so funny. Look, you got hit in the head with a baseball. The guy didn't think it was very funny at the time. But I digress. We have charged particles in the atom. Which one's positive? Protons. Which one's negative? Electrons. Which one's neutral? Neutrons. Okay. So the neutrons don't have a charge. But charges act a lot like magnets do. Have you all played with magnets at all? At the very least, sticking stuff on the fridge, right? My kids have some Brio trains, mostly the knockoff Brio trains. They're a lot cheaper. But they're held together by little magnets. And if you get the car backwards, it will not stick to the next car, because you've got two north poles or two south poles of the magnets, and they repel each other. You turn it around, and you get them close, and they'll just click together. It seems magical. It's magnetism. Electrical charges act much like magnets do. And so if we have opposite charges, a positive and a negative, they will be attracted to each other. If we have two positives or two negatives, they will be repelled away from each other. They'll push away from each other. And so we need to know that. Opposites attract, like charges repel. The charges on these particles in the atom, the proton is the positive one, the electron is the negative one. We can measure their charges in a unit such as coulombs, but we don't need to for chemistry. All we need to know is that they have the same magnitude of charge, just the opposite sign. So we just call them +1 and -1. And so the proton has a +1 charge, the electron has a -1 charge, same charge but opposite in sign. And when you put the two things together, then overall there's no charge at all. We say they cancel out or they add up to 0. So if you add up all the charges in the atom, like a carbon atom is going to have 6 protons and 6 electrons. 6 positives, 6 negatives, adds up to 0. The atom itself has no charge.